Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to solve a problem or how to find the number of moles of water in a hydrate when you're given the percent by mass of a certain element. So let's get into this. So here we're given a problem that aluminum sulfate hydrate Al2SO4 with X number of moles of or molecules of water contains 8.10% of aluminum by mass. So calculate the value of X. So basically they want us to calculate the number of moles of water or the number of molecules of water that's in this hydrate when you're given only the percentage and the formula. So how do you do that? That looks kind of almost impossible to do, but let's focus in on the percentage and understand what the percentage means. And the thing that you have to keep in mind about percentages is that a percent means out of 100. So if you have a percent by mass, that means that you have a certain amount of, say, certain grams of one element or some substance in the whole, right? That you're given. So it's a part out of a whole multiplied by 100. Here, when we're talking about mass percent or percent by mass, it's going to be a certain mass of a part of the whole divided by the whole multiplied by 100. So let's go ahead and write that out because that's going to be key to understanding the problem. So we're given that the mass of aluminum over, that's the part, divided by the whole, which is going to be the mass of this whole thing. So we'll write that down. So the mass of the Al2SO4 3X H2O, and that's going to be multiplied by 100 to get our percentage, right? So we're going to multiply that by 100, and our percentage is 8.10%, right? So this is what a percentage is. So it's a part over whole. Let's if I write the generic equation, it's a part divided by the whole, of which the part is a part, multiplied by 100 gives us the percentage. So the percentage we're given is a percent by mass, and they're saying that this is a percent by mass of the aluminum in our compound. So the mass of the aluminum in our compound is the part divided by the mass of the whole thing multiplied by 100 gives us this percent. Okay, so as we know what a percent means out of 100 percent. So cent, keep in mind century, a century is 100 years. So percent is per 100 or out of 100. So if I add a percent, that means that if 8.10% of this mass is aluminum, then out of 100 grams of this substance here, 8.10 grams of it would be the aluminum or due to the aluminum. Okay, so where do we go from here? Well, keep in mind that we can assume any amount we want, right? If we're getting a percentage, the percentage applies just as well to 100 grams as 200 grams, 50 pounds, 5,000 tons, whatever the case may be, the percentage applies. The percentage is always the same. So we can assume any amount we want. Well, what if we just assume 1 mole of this substance? If I assume 1 mole of this, then 8.10% of that 1 mole is going to be due to the aluminum, but we can do the mass, right? So if we assume 1 mole of the substance, we can use molar masses as the masses of aluminum and this substance here. So all we have to do is calculate the molar masses of aluminum and the substance and put that in the ratio. Okay, let's go ahead and do that. So we got 1 mole of this substance. Let's get rid of the 100 here. So if we get rid of the 100, we have to divide all of this by 100. So if we divide by 100, right? So if I, don't want to write it that way, right? So if I divide by 100, right? If I divide this by 100, and then I have to divide this by 100. So then this cancels out. And then this divided by 100 is then going to give me 0.0810. So then what's going to happen is that I have the mass of the aluminum in this compound here divided by the mass of the compound, the hydrate, Al2SO4 3 with X number of H2O molecules. And then that's going to be equal to 0.0810. Okay. Now, we've got a ratio here, and it's equal to this. So if we assume 1 mole of the original substance, then the percentage, we can use molar masses as the ratio. So I can calculate the molar mass of this, right? And I can calculate the molar mass of the aluminum in here. Now, keep in mind that I have 2 aluminum atoms here. So the total mass of the aluminum is going to be due to the 2 aluminum atoms. So it's twice the molar mass of aluminum. So if I look up the molar mass of aluminum, that's going to be, give me a second, 26.98. But there's 2 of these, so it's going to be 2 times 26.98 grams. Why is it grams? Because I'm assuming 1 mole of this substance, and the molar mass of aluminum is 26.98. I have 2 aluminum atoms, so I'm multiplying that by 2. So this would be the mass of the aluminum in 1 mole of this substance here. So that's the mass of aluminum in 1 mole of this substance. And then now I can calculate the molar mass of this. Now, so if all I need to do is calculate the molar mass of this whole thing here. And when I do that, I'm going to add the molar mass of 2 aluminums, 3 sulfurs, because I have a 3 here. And then 4 times 3 is 12, and I have 12 oxygens. I'm going to add all of that together from my periodic table, because I'm going to find, I look up the atomic masses of each of the elements and add those together, and that gives me the molar mass of this stuff. So when I do that, I get 132, and that's going to be grams. And then I got to add to this water. Now, I have an X here, so I'm going to have a certain number of water molecules in my hydrate here, and that's what I got to find. I can find that using the molar mass. So all I need to do is calculate the molar mass of water, and then I multiply that by X to add to the total molar mass here. So I would have to add to that an X times, and then the molar mass of water. Well, what's the molar mass of water? It's going to be 18.015. 0.01, let me double check that. 1, yeah, 5. And that's going to be grams. And then this is again equal to 0.0810. And now you can kind of see hopefully where I'm going. So I have the mass of aluminum that's in 1 mole of this substance here. That's on top because that's the part. And then I have the total mass of the formula, the total mass in 1 mole of this substance. And it's this part plus this part, which is X times the molar mass of water. So now I have this equal to this. I have X. I have one equation, one unknown. Now all I have to do is solve for X. So now I have to just do some multiplication. So I can multiply this bottom part times this. So I can get this over here. So if I multiply both sides by the bottom part, I can get this over here multiplied and then equal to this. So when I do that, I get, let me see here. So this part is going to be 53,964. So this is going to be 53.964 grams. That's this part 2 times this. Okay. And that's going to be equal to, I'm going to multiply this by this over here. So this is going to be equal to 0.0810 multiplied by this whole thing. So it's going to be 2.132 grams plus X times 18.015 grams. Okay, so now I have this equation here. So next I just have to multiply this out to both of these terms here. So I'm going to multiply this through. So I'm going to multiply this by this and then this by this. And when I do that, I'm going to get 53.964 grams is equal to, what did I get? 27,712, 27.712, let me double check, 69. Okay, I got more digits than I need, but that's okay. And that's going to be grams plus, and then I'm going to multiply this by this, and then I'm going to get X multiplied by, what is X going to be multiplied by? 1.45921. 1.45921. 45,921. Next, I gotta add, I'm gonna subtract this from both sides to get the terms on the same side. So this has no X. So the no X term gets moved over here or subtracted over here. And then this X part stays on here. So when I subtract 27, so I'm going to subtract 27.71269 grams from both sides. 27.71269 grams. When I do that, I'm going to get 26.25,131. So I'm going to continue up here. So it's going to be 26. Oops, hold on a second. Yep, that's right. 26.25131. So 25,131 grams. That's going to be equal to now this part here, X times 145, 1.45921 grams. Okay. And so now all I need to do is divide both sides. So I'm going to divide both sides. so I can get X. So 1.45921 grams. And on this side, 1.45921 grams. So this cancels out. And so then I calculate this. And when I do, I get 18 is equal to X. So that tells me that I have this value here. I have 18 water molecules in my substance. And so that, ladies and gentlemen, is how you solve this problem. I hope this is helpful. If you enjoyed this video, if this helped you in any way, then please, by all means, like the video, share the video, hit that like button over there somewhere. And also subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you would like me to cover, or if you have a question or a problem you need help solving, put that down below. I would love to help you with that. Thanks for joining me and have a great day.